Hello, good morning everyone. Today we will be starting with the new topic and the new unit, that is trusses. So basically what are trusses? We will be studying about the how to analyze them and what are the methods to analyze the trusses. So first of all you need to understand what is trusses. So trusses are the structures in which all the members are subjected to axial loads only. Okay, so that means only axial loading means tension and compression. That means there is no bending involved. So that type of structure, those in which only axial loadings are involved, uh, that type of structure is known as trusses. Okay, in this you can also say that the bending moment is zero everywhere in that structure, so that is known as trusses. So second point is bending moment is zero everywhere in the structure. Only which forces will be involved? Tensile forces and compressive forces. Okay, now there are some other structures which you may uh, see that this is also a type of a truss, but there is a difference between those structures and the trusses. So that type of structure is a frame. So what are the frames? Frames are the structures in which the members are subjected to bending also. Okay, in addition to the tension and compression, there is a bending also involved. So this is the diagram of a truss in which this is the one member, this is one member, this is another member, this is another member, and these are the other members. Okay, and it is simply supported, and the loading is at this point. So you can also see that this structure is having loading at the joints. So this is also, you can make a definition of a truss, that in which structure the loading is at the joints only, that type of structures are known as the trusses. And if the loading is within the span, that means if there is a loading within the span, there will be a bending in the structure, that means it is a type of a frame. Okay, so this is also a similar type of structure. This is, you can see, this is a truss and this is a frame. Only the difference is, in case of truss the loading is at the joints, and in case of a frame you can see that the loading is within the span. So if loading is beneath the span, you can see, if loading is in the span, that will try to bend the member. Okay, so this is trying to bend the member like this, and there will be a bending involved. If bending is involved, that type of structure is not a truss, it is a frame. So I hope this point is clear, what is the difference between a truss and a frame, and now you will easily identify that this structure is a truss and this structure is a frame. Okay, now we come to the next point, that how to analyze the trusses. What are the assumptions involved in it? So concept, these are the concept assumptions in the analysis of the trusses. Okay, all members must be straight and connected by a smooth pin. So that means all the members should be straight. If this member is curved like this, that is not possible. All the members should be straight and connected with a smooth pin. That means it is connected with a smooth pin here at the joints we are talking about. The member should be straight. Okay, it should not bend. If members are curved, the bending moment will exist. Okay, if one member is curved, suppose you can see that if I will make this diagram here, if it is bended like this, and I have told you, in case of a truss the loading is at the joint. If you, it will try to bend, move this structure inward, so there will be a bending involved. Okay, this will be bending like this, so that means it will try to move here, and this structure will try to go out like this, and there will be a bending involved. So this will bend the structure due to this eccentricity. If there is an eccentricity, this will try to bend the member, and that means this is not possible in case of a truss. Okay, so if the members are curved, the bending moment will exist in the members, and structure cannot be called as a truss. So this is the assumptions based on the trusses. So you can see here I have made the diagram in which it is showing the eccentricity in this diagram, so this is not possible. You can say that member AB bends, not, therefore it is not a truss, it is a frame. Loads, second point is loads must be applied only at the joint. This the point I have already discussed, that the loading must only be at the joints. Otherwise, if the loads are applied at the intermediate location of the member, that will try to bend the member, and you can say it is not a truss, it is a frame. Then they will bend and it cannot be called as a truss, so it is called as a frame. So if this is the case, this is a frame structure in which loading is at intermediate of this span, so it will bend, there will be a bending moment in this structure. Therefore you can say this is not a truss. In a truss, the total number of members M and total number of joints J are related by. So in a truss, the total number of members are M and the total number of joints are J, and they are related by M equals to 2J minus 3. So how come this uh, definition come through that these are related like this? So you can see that for making any truss, first of all, how many members are required. Suppose I am making a truss here, okay? So first member this, second member this, and third member this, okay? So now I have made a truss here. So for making a simple truss, triangular truss, I required minimum number of members, that is 3. Minimum number of members are required are 3, and number of joint required are 3. 1, 2, 3. For number of, if I am making a simple triangular truss, so number of members required are 3 and minimum joints are required m. Okay. Now for adding one more joint, number of members required are 2. Again I am adding one joint, then again 2 members are required. So after this, after simple triangular truss, when I am adding the joint, 2 more members are required for a single joint. So if we are talking how many members are required, initially we are required, after this you can say these are initial case, okay? So how many members are required? 2 times the joint, 2 times the joint, 2 times the joint. If I am adding 2 joint, that means 2 times 2, that is 4. 1, 2, 3, 4. So 2 times joint and minus the initial members that are, and that this is always available at the initial stage. So we are neglecting that part. So how many members will be required? 2 times the joints. Okay. So for the first 3 joints, you can write down here. For the first 3 joints, 3 members are required. For each additional joint, if we are adding one more joint, 2 members are required. So we are having an equation that number of members required will be equal to 2 times the joint minus the initial member. So this will give the how many members we are required to make a truss. So this is the relation between member joints and joints. If the above condition is satisfied, so we get the stable triangulated determinate truss. Now if we are making this equation can be related into 3 times, that if m equal to 2j minus 3, that means it is a perfect stable truss. If m is less than 2j minus 3, that means it is unstable or deficient truss. If m is greater than 2j minus 3, that means it is a redundant truss or indeterminate. Okay, it is deficient, and one case is of deficient when m is less than 2j minus 3, and one case is m is greater than, that means it is a redundant truss. So you can see that with that equation you can derive the trusses into 3 types, that is, one is perfect, unstable, and redundant. Okay, suppose this is a question here. So now for the structure shown in the figure, bending moment exists in the member. So if this is the structure here, So where is the he's asking that in this figure bending moment exists in the member. So in which member there is a bending moment exists? Either it is AB, either it is AC, or he's saying both AB and C and none of no members. So you can see that I have already marked the answer here, but how come this is the answer? If anybody is having a doubt, you can say that I am saying that in this structure there will be no bending moment in any of the members. Why? Because there is no loading in this structure. If there is no loading, there will be no bending moment. I have not given the loading here. If no loading is there, so no bending moment is there. So I hope this point is clear. Now we come to the second part, that is you can say that this is the structure. Okay, so this is a truss. In this member is one member, two member, three member, four member, five member, and six member, and he has given that no joints here. There is no joint at this point, so that means 1, 2, 3, 4, 5, 6. Number of members are 6 and number of joints are 1, 2, 3, 4, 4. So we will put these values in the equation, that m equal to 2j minus 3. So how will calculate? Members are here 6. You will be having a doubt that members are 6 here. So according to the equation, we have equation 2j minus 3. So we will relate with this equation. Okay, number of joints are 4, so 2 times 4 minus 3. So 8 minus 3, that is 5. So we are having a 6 member, that means members are greater than 2j minus 3. So we are having a equation members are greater than 2j minus 3. That means if members are greater than 2j minus 3, it is a redundant structure. We have already discussed that. If m is greater than 2j minus 3, that means it is a redundant truss internally, and or indeterminate. It is a indeterminate structure in which m is greater than 2j minus 3, and if m is less than 2j minus 3, it is a unstable or deficient truss. So with this you can analyze the trusses. I hope these points are clear with you. Now we come to the next concept, that is what are the methods of analysis of the truss. If we are having the methods of analysis of the truss, there it can be divided into two parts, that is methods of joints and methods of section. In this we have to discuss the two uh, basic methods that are involved in analyzing the truss. So what are those methods? One is method of joints and method of section. This name also define its method, that what type of method is it. When we are talking about the method of the joint, that means we will be dealing with the joints at that point. We will be making an equilibrium at the joint. And when we are talking about the method of the section, that means we need to cut any section at that point, and that I will tell you that when how to go with these methods. What are the steps involved in the method of joint? What are the methods involved in the methods of this section? So I hope you guys are clear with this concept, that what are the trusses and what are the frames, and how will you analyze the trusses, and what are the assumptions involved in the trusses, how the member should be straight, what type of loading should be there. Loading should be at the joints only. So these are the things that you need to keep in mind. So for this lecture, this much is enough, but from next lecture we will be going in deep with the trusses, that how we will be analyzing the trusses, what are those two methods to analyze. Thank you very much.